In our previous set of videos, we were looking at designing an experiment. Well, suppose that 6 out of 10 patients suffer from some disease and they're cured after receiving a particular treatment, right? We talked about an experimental design where you would have a treatment and then you have a control. That control either gets the gold standard treatment or gets a placebo, and then we're comparing that to the treatment group, which is the one where we want to see if our variable of choice has an impact on that response variable. So we have an independent variable and what happens to the dependent variable. Well, let's suppose for these 6 out of 10 patients, they're cured after receiving a particular treatment. What we want to know is, did this happen because of the treatment and the fact the treatment was effective, or would this have happened even without the treatment? Well, to answer these types of questions, we need to understand the laws of probability. So over the next couple videos, we're going to look at different probability distributions and better understand the idea of probability. Ultimately, what we're trying to get to is our ability to extrapolate from what's happening in our sample to what's happening in that greater population. So probability is a number between 0 and 1 that's assigned to a possible outcome of a random event. When we have a discrete probability, then we're looking at the number of times a specific circumstance occurs out of those possible values. When a variable is continuous, the probability of a specific event or observation may not make sense, such as the probability that a person's exactly 66.875 inches tall. So when we have continuous random variables, we're interested in the probability of a range of values. So we're talking about probability. For example, if we toss a coin, which I just threw across the room, what's the probability of the coin getting heads? Well, there's 2 sides to the coin, and one side is heads, one side is tails. So the probability of tossing a coin and getting a head is 50%. Now, ultimately, we want to create what is called a probability distribution. A probability distribution is a list of all the possible outcomes and the probabilities associated with each outcome. This is similar to the frequency distribution that we looked at previously, but instead of describing the past, which is what a frequency distribution does, a probability distribution describes how likely some future event is. So just to remind you, when we talk about a frequency distribution, a histogram is a frequency distribution. When we were looking at handspan, this looked at how many people had a handspan between 19 and 20 centimeters. So we could create a histogram that showed for our sample how many people fell into these different range groups. And if we scroll back, mind the scroll for a second here, and we look at our frequency distribution tables like we see here, that's relative, here's frequency. But then we could count how many people had a certain opinion to a question. So all of that was describing how many people fall into different categories or different ranges of numbers within that sample. What we want to do is go from that frequency distribution that's describing the sample and the past to our probability distribution that's describing how likely some future event is. Now, when we have a probability distribution has 3 characteristics. The probability of a particular outcome has to be between 0 and 1. So either there's no chance of it happening, 100% chance of it happening, or something in between. You can't have more than 100% chance of something occurring. The outcome is also mutually exclusive. So what we mean by mutually exclusive is that if you fall in one category, you don't fall into another. And I have no idea where I put my coin. But if we toss the coin and we get a head, then the outcome here is a head, not a tail, right? You can't both be a head and a tail at the same time. You're either a head or you're a tail. So mutually exclusive. And collectively exhaustive. As we look at our probability distribution, we need to know all the different possible outcomes. So we're assuming that all different possible states are known. We'll talk more about making sure that you know all those possible states when we get into things like reinforced learning, when we get to our machine learning. But we need to have all the different possible outcomes. So here we're assuming that it's either going to land on heads or it's going to land on tails. There are no other options, right? It can't land on its edge, for example. Okay. So let's look at tossing coins. So suppose we're interested in the number of times that heads occur when we toss 3 coins in the air. So I toss the coin in the air, and the first outcome I get, let me just grab a little marker here, I get tails. Then the second time I toss it, I get tails. The third time I toss it, I get tails. How many heads did I get? I got 0. Okay. Second time I toss it, I get tails, then toss it again, tails, next time heads. Number of heads, 1. Okay, keep going. Toss it, get tails, toss it, get heads, toss it, get heads. Number of heads here is 2. Okay, and I'm just gonna populate this here with information from previous runs that I've done. So I've tossed it in the air and I've got these number of different outcomes. So this time I did it the 5th time and I got all 3 heads. And this time was heads, let's say tails, heads. Now this time we got 2 heads. And this time here, heads, tails, heads. That's 2 heads there. What else do I got here? Tail, 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 tail. And let's say the last time we go heads, tails, tails, and we get 1. Okay, so from this information, we are going to look at the probability distribution for the number of heads. So in order to create this probability distribution, I need to create a table that has all the possible outcomes. So we are going to be collectively exhaustive here. And mutually exclusive, you can only fall into one of these different options. So because each round we toss the coin 3 times, your options are 0 heads, 1 head, 2 head, or all 3 heads. So those are our options here, 0, 1, 2, 3. All right, so then in this case, from our sample here, we had 1 time where we had 0 heads. And we had 3 times where we had 1 head. And what do we have here? In terms of 2 heads, we had that 3 times. And then 3 heads, we had that once. So the probability of each outcome is going to come from the fact that we did 8 different runs here. 1 divided by 8 gives the probability of getting 0 heads, which is 0.125. 3 divided by 8 is what, 0.375. And total number of 3 heads, we have 1 out of 8 times that occurred, we get 0.125. Okay, and we add all of those together, 6, 7, 8, we get that should equal 1. Okay, so we've created a probability distribution here. Does our probability distribution satisfy our 3 characteristics? What were those 3 characteristics? Well, they were that all the outcomes were between 0 and 1, which we have here. 0.125, 0.375, those are between 0 and 1. The outcomes are mutually exclusive, right? So if you had, if you fell into one category, you didn't fall into the other. And collectively exhaustive, we have shown all the different possible outcomes here, 0, 1, 2, or 3 heads, and we total up to be 100%. So now I want to know is what is the probability of getting 3 heads? So what is the probability here that x equals 3 when you toss the 3 coins? Well, the probability that we get 3 heads is going to be that 12.5%. What's the probability of getting at least 1 head? So what's the probability that x is greater than or equal to 1. Well, that is going to be this outcome here of 0.375 plus 0.375 plus 0.125. In other words, it's all of the options except for having 0 heads. So at least one head is 1, 2, and 3. So we could take our 100% and subtract the 12.5% to find the probability of getting at least one head, or we could simply add up 0.375 plus 0.375 plus 0.125 to find that answer. All right. So in this video, we've looked at is how we would create a probability distribution from a coin toss. Throughout the next couple videos, what we're going to be looking at is discrete probability distributions, and we're going in, and then we'll look at continuous probability distributions in the subsequent videos.